Hello everyone, good afternoon. Today I welcome you all in the course of Functional and Conceptual Design NPTEL course offered by Department of Design, IIT Madras. So, what we will learn in this session is whatever we have learned since last 12 week. So, I will try to provide you a small summary of all the week from starting from week 1 to week 12 so that you have a quick revision of all the week from week 1 to 12. So my name is Gaurav Kumar. I'm a PhD research scholar at Department of Design, IIT Kanpur, and I'm also a Prime Minister Research Fellow. So I'm teaching you as my PMRF THE here. So these are my research interests where I'm currently working in the area of assistive technology, assistive medical devices for mobility aids, rehabilitations technology, human-centered design, prosthetics and orthotics, inclusive product design, smart mobility solutions, biomedical instrumentations, design for inclusive society, and AI in the design, and design educations and universal design. So these are my area where I'm currently interested, and my core area is assistive medical devices. Okay, so let's start. So the coming to the section 1, week 1 course introductions and design process overview. So the course of functional and conceptual design frames engineering design as a rigorous, systematic, and human-centered discipline rather than treating design as an ad hoc adjunct, adjunct to analysis or manufacturing. So the course positions it as the logic that connects needs, functions, and realizations. So this implies a deliberate the shift from intuitions to methods, from inspirations to structure iterations. Okay. So the design process through through repeating a loop of analysis, synthesis, evaluations, and tightening fidelity between intent and outcome. So each loop converts ambiguity into clarity. What began as a fuzzy idea became a functions, then a specifications, and finally an embodiment. So the process is traceable and auditable. So choice can be justified and improved. So innovations here is not accidental novelty but the integrations of creativity with engineering constraints. So decisions are supported by models, data, and prototypes. So creativity is uh, encouraged but disciplined. So by the end, students understand how functional reasoning scaffolds robust conceptualizations that stand up to feasibility, cost, reliability, and user value. Okay. So so uh, the summary considerations. So the summary consolidates the week 1 to 12 into a coherent narrative from opportunity sporting to concept generations, from trees ideations to screening and scoring, and finally to embodiment readiness. So it equips you with a transferable playbook for a complex product design. Okay, so now moving towards the next slide. So the course vision and philosophy. Okay, so the course vision is structured innovation guided by logic. So we move beyond the clever ideas toward defensible decisions grounded in evidence and transparent trade-off. So this demands repeatable procedures and explicit criteria so that two component team would converge to a similar conclusion. So to mindsets anchor this version. So design thinking and system thinking. So design thinking and ensures the empathy with users and practical context. Systematic systems thinking ensures we model interactions among parts, people, process, and environments together. So they prevent local optima that undermine whole system performance. So the user orientations and technical feasibility. Okay, so evolve desirable sets directions, feasibility bonds, and search viability sustains the outcome. Sustainability and ethics are not afterthoughts, so they shape early choice on materials, energies, safety, and life cycle. So finally the philosophy is reflective practice. We institutionalize the learning by documenting rational testing assumptions and updating models. So reflections after each iterations sharpness judgment and accelerates the progress. Okay, now moving towards the next one. So next one is nature and scope of design. So design is a iterative, goal driven and multidisciplinary, and it balances the functions, ergonomics, statics, cost, manufacturability, and sustainability under a real uh, constraints of time and information. So designers craft is to navigate the conflicts without losing coherence. So the workflow cycles through analysis, synthesis, evaluations, and communications. So analysis clarify the problem, synthesis generates the alternatives, evaluations test them against the criteria, and communications align stakeholders. So the loop continue until a convergence. Okay, so next is trade-off analysis is a critical. So there is no single based solutions independent of context. So we select a optimal compromises aligned with weighted objectives. So tools like Pareto reasoning and multi-criteria methods turn judgment into method. So design links engineering science with creative explorations. Physics and economics limit the feasible. So creativity explores the possible structured, process selects the valuable. So that coupling is the scope of this course. Okay. Now moving towards the next slide. just a minute, sorry. Next is stage of product development. So what we learned from the week one is that opportunity identifications and mission statement, customer needs analysis, requirement clarifications, concept generations, concept screening and selections, embodiment and detailed design phase, prototyping testing and feedback iterations, and lastly launch and post market evaluation. So the process began with opportunity identifications and the mission statement that anchors scope. We then elicit and intercept the customer needs, translate them into specifications, and decompose the system functionally to expose the solution space. Okay. Next is to concept generations proceeds in two modes: intuitive, that is brainstorming gallery or 635 morphological chart, and logical, that is a checklist, analogy, heuristics, and a trees. So we then apply a concept screening, qualitative, and concept scoring, that is called quantitative, to coverage the objectively. Okay. So embodiment and detailed design convert the selected concepts into structures, materials, and tolerance, supported by modeling and prototyping. So testing close the loop, feeding corrections into specifications and architecture. So launch is not an end but a checkpoint. So post market evaluations, the update assumptions, validates the trade-offs, and informs the next cycle. So embodying the learning into its platforms and product families. Okay. Now next is team building and customer role. Okay. So high quality design is the product of course functional teams, mechanical, electronics, software, manufacturing, and human factors must be architect. So early to avoid expense, late fixes, clear rules set the artifacts, and cadiness create a flow. Okay. The communication structures the review, decisions, logs, change control, turn collaborations into accountability. So the voice of the customer VOC remains the north star. Every requirement and trade-off should trace back to the user value. Okay. Next is reverse engineering and trade down. Build the functional literacy by analyzing the existing architecture and failure modes. So team inherit the proven patterns while spotting opportunities to differentiate. So a culture of reflection and respect strengthens the collective intelligence. When teams debate the criteria, document rational, and revisit the assumptions, so they reduce iterations cost and improve the design integrity. Okay. So this is the what we have learned in the last in the first week of this courses. Okay. Now we are moving into the week second, that is called opportunity identifications and need analysis. So whatever we have learned in week 2, now we are quickly try to cover up the all the concept in this slide. Okay. So that next is identifying the opportunity. So detect and meet the user needs and technological gap. So use the trend mapping, patent landscape studies, and field observations. So our focus is on the pain point in a daily activities or industrial process. So then we link observed needs to a social impact and economic value. And then we also increase to encourage the designers to be keen observers of the context. So basically, opportunity identifications start with a keen observation of pinpoint and inefficiencies across a context: homes, clinics, factories, farm. So we look for a friction, delay, rework, hazards, signals of value waiting to be created. So macro tool trend mapping technologies, scouting the like patent landscape, frame a strategic contest, micro tools, which is a field notes, shadowing diaries, so reveal the lived uh, realities. So this dual lens prevent the fashionable but irrelevant projects. Okay, so an opportunity is stronger when it linked to a social impact, accessibility, affordability, safety, sustainability. That link the clarifies the stakeholders and motivates adoption. So the habit is proactive designers create opportunity for framing a constraints as levers. The question is not what can we build, but where can we remove meaningful frictions. Okay, so this is the what identifications opportunity. Now we are moving into the next slide called a framing design opportunity. Okay, so a good problem frame is a broad enough to permit a creativity yet bounded enough to focus effort. So it names the stakeholders, context, constraints, and measurable outcomes. The framing incorporates the regulatory, environmental, and infrastructural realities, and it tests the fit with institutional strategy, competencies, and platform to ensure feasibility and leverage. So traceability is mandatory, need, requirement, and specification. So if we cannot trace a requirement to a need or a test to a spec, the chain is weak. So timeliness matters. So the frame should reflect the present urgency and future relevance, preventing the uh, elegant answer to the fading questions. Okay, so this is the what we have learned. Like as I have written in the slides, define a broad but bounded problem statement, include the stakeholders, environment constraint, align it the problem framing with organizations or research objective, or ensures the relevancies and timelines of the identified opportunity, and maintain the traceability for a needs, requirement, and specifications. So if you cannot trace a requirement to need or test to spec, the chain will be a weak. Okay. Now moving towards the next one is tool for opportunity spotting. Okay, so SWOT and pastel, suitable idea and market structures, policy and technology vector. So they reveal where threats can be converted into opportunity. So ethnographic method uncover a latent needs in visibility survey, workarounds, tacit knowledge, non-verbal cues, scenarios building, and then explores the future to stress test idea against uncertainty. So the system mapping visualize the flow of materials, energy informations, and money. So it exposes the leverage point where small design change produce a large effects. Okay, so maintaining the opportunity logs institutionalize the serendipity. Weak signal today may become strong next semester. So design is as much curation as creations. Okay. Just a minute, sorry. So next one is need analysis process. So the need analysis convert the observations into actionable requirements. So interview focus, group contextual inquiry, and use the analytics from a triangulated evidence base. So we distinguish the explicit from a latent needs. So the latter emerge by interpreting the behavior and context rather than quotes. So they often unlock the breakthrough value. So brainstorming the synthesize the findings, prioritizations matrix, order them by impact and frequency. So the output is need statement with acceptance criteria and boundary. So this artifact guides the subsequent specifications, keeping teams aligned and scope disciplined. Okay. So now we are slowly moving towards the week 3. Okay, week 3, gathering interpreting the customer needs. Okay. So we have section 3, a week 3, gathering interpreting customer needs. Okay. So just a minute, sorry. So the first is voice of the customer, VOC. So voice of customers ensures a human relevance. So we capture our experience, frustrations, aspirations, and contexts that shape value, perceptions, and methods include observations, interview, surveys, and instrumentation. So we seek not only what users say, but what they do and why. Okay, so dissatisfactions, delays, errors, and fatigue are diagnostic signals. So we bracket the biases and validate with a multiple source. Qualitative, perhaps easy to use, and must be translated into measurable targets. Setup time, which is less than 60, okay, and forces which is less than 15, and so that translations enables the engineering and verification. So voc is integrated into a specifications matrix, so nothing is lost as the project moves from words to numbers to parts. Okay. So structuring the customer data. So raw data requires the structure, and we cluster needs into themes like functions, usability, safety, aesthetics, sustainability to reveal the patterns and tensions. Okay, so affinity diagrams visualize the relationships pairwise comparisons to ASP prioritizations them with a discipline. So we record the assumptions and evidence to avoid litigations. Okay, so each need is linked to a functional response, how the product will address it, uh, forming a traceability matrix, gaps identify a research or concept work still needed. Okay, so the result is coherent narrative of value that can drive architectures and trade-offs. Okay, now we are moving towards the next one is translating needs into insights. Okay, so we classify the features using a Kano model. Basic, that must be performance, linear satisfactions, excitement, delighters. So this infos resource allocations and differentiation. So descriptive needs convert to a technical goals with units, tolerance and test methods. So ambiguity is removed and validations becomes the possible. So traceability keeps the chain intact during change when a spec shifts, so we know which need and taste move with it. So this guards against requirement drift. So insights though became a design levers, not mere statements. Okay, now we are moving towards the next one. So yeah, now we are slowly moving towards the week 4, converting needs to specifications. Okay, so where what we will learn here, we will define the specifications, quality functions, deployment, CQFD. Okay, and benchmarking competing products, balancing trade-offs, and yeah, so lastly we will see the balancing trade-offs. Okay, so now let's just start. So our first is defining specifications. Okay, so specifications are the contract of intent, clear, measurable, variable. So they define performance envelopes. For example, mass is less than equal to 1 kg and noise is less than a 30 dB. Okay, so good speech are necessary and sufficient. No padding, no wish listing. So they reflect the stakeholder, prioritize and manufacturing realities. Okay, so space enables the benchmarking, simulations and test planning. So they also enable change control, deviations, require rational and impact analysis. So by turning adjectives into numbers, we make creativity testable. Okay. Next is QFD, that is quality function deployment. So quality function is basically house of quality, maps of what customer value to how engineer will deliver it. Okay, so relationship strengths and directionality surface where effort pays off. So cross functional participations ensures marketing, design and productions agree on prioritized and constraints. So this silos decisions. So correlations matrix proof reveal the parameters conflicts and synergies guiding. So trade off early, we avoid a late costly compromises. QFD elevates the quality by aligning design energy with customer leverage points. Okay. Now we are benchmarking the competing products. Okay, so benchmarking anchor ambitions to market reality. We analyze based in class matrix architecture and user experience patterns to set the targets. So we learn from the strengths and weakness, adopt the proven patterns, avoid known pitfalls, surpass gaps, and competitive towardness inform cost and process choice. So benchmarking became a guardrails in concept selections and later tests. So they also support the positioning and value uh, proposition. So thus the benchmarking prevents the reinventions while sharpening the differentiations. Okay. Now we are moving towards the next slide, which is balancing trade-off. Okay, so design lives in a trade-offs: performance versus cost, strength versus weight, and precision versus manufacturability. Compromises are invertible. So MCDA with a weight and scores the formalize the judgment. Sensitivity and robustness analyze the test stability. Documented rational preserve institutional memory. Okay, so we prefer a non-compromise solutions when possible, for example trees, but when a trade-off remain, we make them explicit and traceable. So balance optimizations beats and dimensional maximizations. Okay, now we are moving towards the week 5, that is functional decomposition and analysis. So what we will learn here regarding functional decomposition and analysis, we will also see a functional reasoning, black box approach, and a functional flow hierarchy. Okay, and advantage of functional decompositions. Okay, so these are the topics we will cover into week 5. Okay, so now we are moving towards slide. So we will cover the functional reasoning. So let's understand. So we prioritize the purpose before form. So what transformations must occur from input to output? Okay, so this abstractions enlarge the concept space, and explicit input output definitions prevent the scope creep and omissions. So redundant or low value functions are eliminated early. So goal oriented reasoning supports the parallel explorations and a clean interface. So it reduces bias toward familiar embodiment. So functional clarity is the a springboard for creative yet disciplined concept generations. Okay, sorry. Now next one is black box. So the black box model the system as an input, transformations output, tried across energy, material, and a single flow. Okay, and details are deferred. So boundaries and interface became the explicit. External dependencies are surfaced. So this reduce the integration surprises later. Okay, so by suspending embedment, we preserved a flexibility to consider a multiple architecture. So we design what must happen, not yet how. Okay, So said black box diagram team in intent in the minutes. Okay. Now next one is functional flow and hierarchy. So we decompose the main functions into sub functions and map logical order. So dependencies and concurrency became visible. So each sub functions can be solved, tested and iterated. So semi independently, enabling modularity. Hand off and control signal are clarified. So functions trees, block diagrams and flow networks strengthen the cross disciplinary understanding. They also feed morphological charts. So the result is scaffold that invites the systematic creativity. Okay. Now next is advantage of functional decomposition. So benefits includes the clarity, modularity, testability and reuse. So the problem became local solutions became a portable. So troubleshooting improves because failure mode can be isolated to specific functions. Performance bottleneck are easier to diagnose and knowledge assets. So will design functional blocks, seed feature products, shortening the cycles. Architecture work became faster and safer. So decompositions turn complexity into a set of solvable sub problem. Okay. Now moving towards the next. So yeah, moving to the section 6, week 6. So here we will see the product architecture. So we will slowly see the meaning of product architecture. Okay. And modular versus integral architecture and interface definitions, design strategy. Okay. So these are the things we will see over here. So first is meaning of product architecture. Okay, so the product architecture maps the functions to a physical components and defines their arrangement and interaction. So it manifests the strategy, performance, cost, service and upgrade the paths. So architecture influence the assembly time, quality yield, repairability and recyclability. So early choice create a long shadow, clear architecture reduce the integrations risk, enable parallel development and ambiguity. So here is expensive later. So architecture is the hinge between conceptual intent and industrial reality. Okay. So now next is modular versus integral architecture. So modular designs ease customizations, late diffractions and service. So they suit the turbulent market and long families. Integral designs maximize compactness and performance. So where interface are tight. So many products are hybrids, modular at the system level, integral within modules. So the art is choosing the right granularity. So life cycle economics, volumes variant, warranty, upgrade rhythm. So inform the choice more than a test. Platforms magnify benefits. So explicitly articulating the rational avoid accidental architectures. Okay. Now next is interface definitions. So interface are contracts, mechanical fits and tolerance, electrical level and connectors, data schemas and timing. So they must be unambiguous. So good interface localize the change. So a module can evolve without rippling the failures. So they also enable a supplier ecosystem and third party innovation. So verifications plan should include a interface tests. Many field failure are interface failures. So standardizations reduce the frictions and interface make the complex system legible and governable. Okay. Next is design strategy. So use up platforms to reuse course across variant. So standardize the parts and process to reduce the cost and risk. Practice concurrent engineering. So DFA, DFM, DFS guide the geometry and routing early. So design for serviceability, access, faster diagnostic and incorporate the sustainability. So materials, disassembly, recyclability, engineer energy. Okay, so the architecture is a strategy, not merely structural. So it includes the choice that influence a decade of the products. So now we are slowly moving towards the week 7 concept generations intuitive methods. Okay, so what we will learn in the week 7? We will learn role of the creativity, okay, and brainstorming and gallery methods, and 635 brain writing and morphological chart methods. So these will be we will learn in week 7. Okay, just a minute, give me a minute, take some water. So the role of the creativity. So creativity opens the solutions space. So we increase the quantity before judgment to avoid. So premature convergence and fixation. So physiological safety and facilitations matter, and void idea uh, piggybacking and deferral of criticism produce affluence and novelty. Diversity boosts the range, and creativity is not chaos with when guided by function. So the best sessions tie back to needs and space to stay relevant. Outputs are documented for a later clustering, screening, and hybridizations. Okay. So next one is brainstorming and gallery methods. So the brainstorming generates the raw material, rules defer the judgments, build on idea, protect flow and time box and promotes the sustain energy. Okay, so the gallery method uh, externalize the stakeholder for for walkthrough, critic and associations. So visual juxtapositions triggers a new combinations. Okay, so so this cycle generate the discipline, associate the refine, and creates the collective ownerships and reduce the bias from loud voice. Ideas are evaluated on merit, not hierarchy. So the gallery became a living map of the team's imaginations. Okay. So now moving towards the next one. So now next one is 635 brainstorming. Okay. So what is the 635 brainstorming? So six people, three idea each, and 5 minutes round. So silent writing limits domains the bias and isolate the across a pollinations. So passing a seeds ensures continuous building and mutations of idea within 30 minutes. So the team produce a broad layered set of options. Okay, and writing artifacts improve traceability into later selections and IP. So the structure balance spon- uh, spontaneity with method. So 635 is creativity with metronome of fast fair fertile. Okay. Now moving towards the next one. So our next one is morphological chart method. So we list the functions and enumerate the solutions options per function. So by combining column choice, we form a concept configuration systematically. So this exposes the blind spots and invites the unconventional pairing. So it also ensures the completeness. No function is left unsolved. So teams can score the combinations quickly for plausibility before deeper evaluation. So chart persist as a design knowledge. So morphological analysis is the bridge from functions map to concept families. Okay. Now slowly moving towards the next week. Now that is a week 8 structured and logical concept generation. So we will see in this week that, and we will also learn that systematic concept development, heuristic and trigger techniques, checklist analogy, and hybrid concept generations. So these are the concept we will quickly see. So let's see, the first one is called systematic concept development. Okay, so the logical methods discipline our creativity. So we document the assumptions, boundary conditions, and rationale to enable review and learning. So we maintain a dual track thinking, diverse to propose, converge to structure, then diverse again with new insights. That is, cadence matters. So structured explorations reduce bias toward the first work idea and improve the coverage of the design space. So it also speeds the later selections. So method turns inspirations into asset, not a risk. Okay. The next is heuristic and trigger techniques. So heuristics are experience based rules and new thinking. separate, combine, invert, multiply, simplify, relocate, buffer, standardize, and trigger questions eliminate, reverse, substitute, dynamize, and shake assumptions lose. So they instantiate the cognitive referring. So use deliberately heuristics prevent fixations and open path to elegant simplifications or performance leaps. So we record which triggers yield value for future reuse. So thus the heuristics are repeatable spark for inventions. Okay. The next one is checklist and analogies. So checklist ensures the coverage, safety, reliability, assembly, cost, service, environment. So they reduce the omissions, errors typical in the fast ideations. Analogy import the patterns from other domains. So biology, biomimicry, aerospace, logistics, the mapping must respect the physics and context. So the cross industry learning often yields the counterintuitive but robust idea. So we test the analogy with quick models to filter poetic from practical. So together these tools broaden the search without losing the grounding. Okay. Now next one is hybrid concept generations. So we blend the intuitive divergence with a logical uh, scaffolding, for example, brainstorming, morphological mix, heuristic pass, triggers. So creatives and analysts pairs to cross the check novelty and feasibility. So early lightweight screen must meet the constraints, avoid the wasted cycle. So quality sketch feed into quantitative pre-screens, forming a pipeline of maturing the concepts, documentations, enable the fair comparison later. So hybridizations produce the depth, quality and the breadth variety. Okay. So these were the our from week 8. Now we are moving towards the next. So next is week 9. So here we will see the conceptual design tools like trees and beyond. So we will introduce the trees, type of contradictions and invent inventive principles and metrics, and systematic evaluation and ideality. Okay. So let us see. So the first one is introductions to the trees. So the trees is basically Theoria, Rihenia, uh, Ijobretskin, Jadak systemize the institutions by, this is the full form of the trees. So trees is systemizations in inventions by analogy patterns from vast patent corpora. Alice Tuller, it argues that uh, inventive problems repeat and can be resolved via general principle. So trees reframes the problems as contradictions to be resolved rather than compromise. So it offers the tools, principles, matrix, separations, and strategy trend of evaluation. So the method upgrade the creativity from intuitions to guided the search, and it pairs well with functional reasoning and morphological work. So trees does not replace the judgment, it amplify it with structured options. Okay. So the type of contradictions, let's type of contradictions. So the technical contradictions improving the x versions y, Example, strength is increasing, weight is increasing. So physical contradictions, so the same element must be A and not A, rigid and flexible. So identifying the right contradictions statement is half the solution. So poor statements yield weak guidance. So we define the wording iteratively. So we seek the resolutions, not compromise the compromise. Keep both benefits by changing configurations, timing, space, materials, or a control. So starting contradictions crisply, it directs the inventive energy effectively. Okay. So now next is inventive principle and metrics. So the 40 principles: segmentations, universality, prior action, asymmetry, nesting, dynamizations, etc. are distilled. So strategy, the contradictions matrix suggests the candidate's principles given improving, worsening the parameters. So we treat the matrix as a springboard, not a cage, and it suggests where analog has worked historically. So multiple principles can be combined. So we test the candidates with quick sketch models or calculations. So weak fits are discarded, promising one proceed to concept integration. So the matrix operationalizations inventions as learnable practice. Okay. Now next is system evaluations and ideality. So TRIZ posits the trends of evaluations, examples dynamics, segmentations, integrations, increasing the controllability, and the drive towards the ideality maximize the useful efforts while minimizing harm cost. So ideality offer a directional metric or a road mapping where should the next concept move, and it pushes the simplifications, resource leverage, and harm reduction. So by aligning design with evolution trends, we anticipate rather than react to change. So this reduced by the strategic risk. So trees thus inform both concept move and platform projections. Okay. Please give me a few minutes, then we'll start again. So coming to the week 10, that is conceptual design and detailing. Okay, so here what we will learn, we will see the concept refinement, concept combination and improvement, ensuring robust design, design documentation. Okay, so these are the thing we will see quickly. So coming to the slide. So the concept refinement. Okay, so the refinement uh, improve the coherence between refinement and the concept. Okay, so we tighten the assumptions, reduce the risk, and clarify the interface. So we analyze the performance, cost, safety, usability, and manufacturability. So often revealing the tweaks with high leverage, quick experiments, validates claims early. Refinement is iterative, so each pass the convergence ambiguity into uh, numbers and drawing. So we preserve the alternatives when uncertainty is high. So the aim is feasibility with option, not premature lock-in. So next one is the concept combination and improvement. So we hybridize the merge strengths of a different concepts to avoid a single point weakness. TRIZ principles guide the eliminations of contradictions that block earlier variants, and design reviews surface blind spots, rapid the prototypes, expose hidden coupling. So we adjust the geometry materials or a control to stabilize the behavior. So we track a change and impact to protect the traceability. Improvements are justified by data, not test. So combination turns computing the ideas into coherent based of blend. Okay. Now next one is ensuring the robust design. So robustness means the performance under variability. So we apply tolerance analysis, DOE and FEMA to map the sensitivity and failure models. So we prioritize the preventive control, design out failure over detective ones. So where variability persists, so we add margin or adjust control strategy. So reliability thinking, load spectra environment where is folded in early. So late fix are costly. Manufacturing the capability informs the tolerance. So robustness is the difference between a good prototype and a good products. Okay. Now moving towards the design documentations. So we capture the assumptions, discussions, alternative and rational. So artifacts include the space, functions, structures. So morphs the chart, QFD reviews, risk and test. So documentations enables the onboarding audits, IP and learning transfer. So it turns test sheet know-how into organizational memory. Okay. So change control links, deltas to resonance and effects. Traceability is quality system, not a bureaucracy. So what is not documented is difficult to defend or to improve. Okay. Now moving toward the week 11 concept selections techniques. Okay. So what we will learn? We will learn the structural innovations framework, trees and contradictions analysis. Okay. Inventive principles and regulations, and concept screening and scoring, outcome of the week 11. Okay. So structured innovation framework. So logical design methods are serve as the backbone that complements intuitive ideations in engineering design. So while creativity drives idea generations, Logic ensures that these ideas are examined systematically and developed within a rational structure. So the design process thereby became both imaginative and defensible. So transforming unstructured innovations into a repeatable methodology that can be taught. So test and improve. So one of the most powerful frameworks are structured innovation is TRIZ, which formalize the inventive reasoning through the concept of contradictions resolutions. So instead of treating contradictions as barrier, trees consider them to triggers for creativity, and it moves the designer so from arbitrary trial and error to purposeful explore where every intuitive step is guided by underlying the logic derived from patterns of innovation. So in the later part of the design process concept screening and scoring methods ensures that the every proposed idea is traceable and objectively evaluated. So qualitative screening methods such as the pug matrix helps the narrow down the options based on functional validity viability. So while quantitative scoring introduce the measurable data-based justification. So by integrating creativity with rational decision making, designers achieves the true engineering in integrity. uh, the outcome is not only a noble design but one that reproducible, justifiable, and align the technical and societal uh, constraints. Okay, so trees and contradictions analysis. So the TRIZ methodology, developed by Genrich Altriheller in the mid 20th century, was delivered from studying the hundreds of thousands of patterns to uncover recurring intuitive patterns. So the central observation was that intuitive breakthrough often result from resolving contradictions rather than merely optimize with existing limits. So trees thus provide the designers with structured methods to overcome barrier to innovations. Okay. So, two main categories of contradictions define most design challenge: technical contradictions and physical contradictions. So, a technical contradictions occurs when improving one attribute of a system, such as strength, so lead to the deteriorations of another, such as weight. So, a physical contradictions, on the other hand, arise when the same parameter must exhibit the opposite properties. For example, a surface that should be both rigid and flexible. So by identifying and classifying the contradictions correctly, designers are encouraged to reformulate the problems rather than accept the compromises. So trees promotes the problem abstractions where the focus shifts from the specific case to its underlying the principles, allowing the designers to apply generalized inventive solutions already proven in other contexts. So this method transforms the design from incremental improvements into principle based innovation, so providing a structured pathway to resolve the conflicts that conventional optimizations cannot address. Okay, so now moving towards the next slide. Now next is intuitive principle and regulations. Okay, so the TRIZ offers a compendium of 40 intuitive principles, so each representing a generalized strategy to resolve the contradictions. So examples include the segmentations, universality, prior actions, as asymmetry, and dynamization. So these principles enables the designers to jump beyond the limit of the current thinking by applying solutions patterns that have worked across industries and technology. So the contradictions matrix in a tree serves as the operational guide linking conflicting the engineering parameters to relevant the principles. For instance, if the designer seeks to increase the speed without increasing the energy consumptions, the matrix points towards the inventive directions that holistically resolve the similar trade-offs. So this bridge into intuitions with evidence-based reasoning. So to tackle the physical contradictions, the trees recommends the separation strategy. So in space-time conditions or a system level, these allow the mutual exclusive requirements to coexist. So such as creating materials that are rigid under a load but flexible during the operation. Such strategy allow innovation without compromising the achieving the simultaneous benefit where conventional design would settle for a trade-offs. So by systematically applying these methods, designers can strengthen the nobility while preserving the flexibility, ensuring that each innovative concept remains both creative and implementable. Okay, now moving towards the next slide, that is concept screening and scoring. So once the potential solutions are generated, concept selections becomes the crucial for uh, transitioning from ideations to embodiment design. So the pug matrix or decision matrix is one of the most effective tool for qualitative compromising. So it allows the designer to evaluate the alternative relative, okay, to reference the datum using the simple scale using a plus, 0 and minus, focusing on strengths, so weakness and naturality. This quick comparison helps the eliminate the poor ideas early while retaining the promising ones for a deeper analysis. So following the qualitative screening, the weighted scoring method provides quantitative foundations for decision making. So each evaluations creation such as a cost, performance, reliability and usability is assigned a weight proportional to its importance. So the concepts are rated against these criteria and weighted sum determines overall performance. So this ensures that the final selections is objective, transparent and defensible. So multi-criteria evaluations minimize the subjective bias and encourage the team consensus. So aligning the interdisciplinary teams towards a shared rational. Moreover, the sensitivity analysis can be used to test the robustness of result under varied assumptions, ensures that small errors in judgment do not overturn the design hierarchy. Though this method selections became an act of reasoned convergence rather than arbitrary choice, so preserving the creative intent while embedding engineering discipline. Okay, so now we see the outcomes of the week 11. So by the end of week 11, uh, we acquired that ability to apply TRIZ principles for contradictions driven ideations, allowing systematic exploration of innovations beyond trial and error. So they also became the proficient in using a screening and scoring workflow that enables fair and transparent evaluations of competing the design concept. So this week emphasize the integrating of heuristic creativity with analytical reasoning, where inspiration is validated through logic. Each tool, be it trees, pug matrix or weighted, so scoring contributions to transforming the abstract design intuitions into quantifiable decision making. So students learn to construct an audit trail of decisions, ensuring that every selection step can be revised and improved with the evidence. So this level of documentation strengthens the credibility in the both academic and industrial environment. So ultimately, week 11 lays the foundations for final evaluations and embodiment design process, where the most promising ideas transitions into detailed manufacturable form while retaining the spirit of innovations. Okay, now we are moving to the final course, week 12 final evaluation and course wrap up. So okay, so what we will learn here: the concept scoring process, decision robustness and sensitivity, integrations and improvements, documentation and traceability, and course synthesis and learning outcomes. Okay, so moving towards the next slide. So the first one is concept scoring process. So week 12 marks the final stage of the conceptual design process, where qualitative insights are transformed into quantitative justification. So concept scoring breeds the creative explorations and engineering validations by assigning the measurable value to the design performance across the multiple criteria. So the process began with defining the criteria aligned with voice of the customer and previously established the product specification. So these criteria ensures that the evaluations reflects the user expectations, technical feasibility, and business viability simultaneously. So weights are assigned to each creations through team consensus or pairwise comparison, and numerical rating are given to each concept based on test data or expert evaluation. So the weighted score are then summed to determine an objective rank order among alternative. So through this process designs the making the transitions from subjective performance to evidence based selections, ensuring the transparency, repeatability, and technical deficiencyability. Okay, next is decision robustness and sensitivity. So decision robustness is a critical aspect of concept evaluations. Even well scored concept may under perform if their ranking are highly sensitive to minor variations in weight or assumptions. So therefore sensitivity analysis is conducted to assess the stability of decision under the uncertainty. So designers re-evaluate the score uh, across the different weighting scenarios and observe whether the rank order remains the consistent. So if the significant shifts occur, it indicates the fragility in the decision model. In such a case, dual path development pursuing too closely ranked concepts and can mitigate the risk and maintain the flexibility in downstream stage. So the testing feedback from the prototype and simulations is also incorporated to refine the scores and researching the design performance. So these continuous loop between evaluations and validations enhance the confidence in the final selection. So the documenting the relations and observations, ensuring that the design integrity is preserved and lessons are captured for a future iteration. So a key hallmark for a professional design practice. Okay, now we are moving towards the next slide. Next one is integrations and improvement. Okay, so the integrations phase merge analytical evaluations with the iterative refinement techniques such as the TRIZ and FMEA, that is failure mode and effective analysis, are used to resolve the residual trade-off identified during the scoring. So these structured tool helps the eliminate potential weakness before embodiment begins. So high performing features from a multiple concepts can be hybridized into a single optimized design. So leveraging the strength while mitigating the limitations, this approach reflects the essence of systematic innovations, where the competitions among idea leads to collaborations among functions. So the final integrations step ensures the alignment with broader performance objectives such as cost effectiveness, safety, ergonomic, and environmental sustainability. So in this way, design improvement continue even after selections, ensuring that the chosen concept evolve toward the excellence, the process embodiment, the design philosophy of continue improvement, learning, adapting, and refining through every iterations. Now moving towards the next slide. Next one is documentations and traceability. So effective design documentation is cornerstone of professional engineering practice, and it ensures that every decision from scoring to a final selection is backed by recorded evidence, and rational maintaining such a record supports the auditability, productions, and team knowledge continuity. So all criteria, weight, scores, assumptions, testing outcomes, and feedback loops should be meticulously loaded, and each design choice must be traceable back to its functional and user requirement, reinforcing the chain from opportunity identifications to final embodiment. So this culture of traceability not only enhance project transparency but also accelerates the onboarding for new team members and enables the regulatory or quality compliance, and it transforms the documentations from a bureaucratic exercise into a learning tool. So in essence, good documentation turns design experience into institutional memory, allowing the future projects to begin where the last one ended, not where it began. Okay, so now moving towards the next slide. So this is the course synthesis and learning outcome. So the 12 week course journey from identifying the opportunities to selecting the final concept demonstrates that design is both creative and systematic. So every stage builds the logical on the previous one, so forming cohesive chain: opportunity, needs, specifications, functions, concept, evaluations, and embodiment readiness. So students now understand that creativity without a discipline leads to chow. So while a discipline without creativity leads to stagnations, so the balance achieves through the structured iterations allows the innovations to be both original and reliable. So with these methods, designers are fully prepared to enter the embodiment design phase, where concepts are translated into tangible products. So the emphasis on centricity, system integrations, and data driven validations ensures that the final solutions are sustainable and contextually relevant. So the ultimate take away from this course is a systematic evidence based on empathic design mindset. So a mindset that transforms the imaginations into innovation and vision into viable engineering reality. Okay, so that's it from my side. Okay, so in this lecture I tried to cover the whole 12 big summary in just a single lecture. So yes, I hope this will be really helpful for your examinations point of view. Okay, thank you guys, thank you so much. And if you have any kind of question, query, or anything, you may kindly uh, email me on my email id. Okay, so if you have anything uh, related course examination, you may email us. Okay, I will try to reply you. Okay, thank you guys, thank you so much, thanks a lot, and wish you all the best for your examinations. Okay, thank you.